the certificate. Today I want to share some personal experience about electrical switchgear. In front of me you can see this 13.8 kV switchgear bus bar. In this bus bar I have two internals between one bus controller and four transformer, two spare feeders. So each feeder have different type of components. For some are for protection, some for assemblies, and there is we are using some locker relays for breaker protection for reclosing. So I want to explain something about on a feeder. You can see in front of me this is a feeder, spare feeder, and other alls are in service condition. That's why I cannot touch that feeders. This is spare feeders. That's why I can explain on this feeder. First of all, I want to inform about color coded of wires. Red wires normally we use red wire for VT low, and yellow wire we use for CT low, and gray wire for control circuit, for DC control circuit, and black wire for AC control circuit, and blue wire for auxiliary control. That's why I want to explain these all things with you. In front of me I have this feeder. This feeder have different type of components. Front of upside I have a auxiliary relay, a good auxiliary relay made by Siemens. This all switch gear made by Schneider. This is made by Siemens. This relay have two DC coil in this relay. Each coil rated voltage is 125 volt DC, and two coils in this relay have two coils. So how we test this relay? We test this relay through Frika. We inject rated voltage and check timing of this relay, how much time it takes for closing and for opening this relay. For tripping timing we test through Frika. We inject 125 volts on this auxiliary relay coil and check timing through binary contacts. And then we check how much voltage is pickup voltage and drop off voltage. We start through Frika. We start through this relay through Frika. We start 0 voltage to increase the voltage slowly and check how much voltage is pickup voltage of this relay. Up to up to 60 voltage or 70 voltage is pickup voltage of this auxiliary coil relay, and drop off voltage is less than 40 voltage is drop off voltage. We use for control and for signal this relay. And another side you can see this relay also auxiliary coil relay. The auxiliary relay have one coil, and the rated voltage is 125 volt DC, and we test same like other relay. We inject 125 volts through Frika and check through binary contacts how much tripping timing, and we also check how much is pickup voltage and how much is drop off voltage of this relay. And then I want to explain about the multifunction meter. This is multifunction meter made by Schneider. We use this device for measuring of voltage and current. This is multifunction meter made by Schneider. We use for voltage measuring and for current measuring, and we also take readings for apparent power, active power, reactive power, and power factor. You can see these all things in this multifunction meter. So we inject, we take voltage loop from bus metering VT. Then in bus 13.8 kV is rated voltage, and VT value is 13.8 kV into 115 voltage. Primary side is 13.8 kV and the secondary side is 115 volt is secondary side. and 115 volt is coming in this multifunction meter, and we can see here this values on this multifunction meter. This is electronic multifunction meter, that's why we cannot inject more voltage because this is a small device and our voltage is high and also our current is high. That's why we use VTs and CTs for this multifunction meters. For this multifunction meters and for protection relays for low values. So we have one lower step down transformer for VTs and also step down transformer CTs. And CTs are connected with bus bar, and these CTs and CTs, this feeder CTs is back side to this feeder connected with bus, and the VTs coming from this bus metering, this side bus metering VTs through this VTs. So this is multifunction meter we use for current value, for current value, for voltage value, for power factor, apparent power, reactive power and active power. You can see these all things in this multifunction meter. So this is multifunction meter, and then next one is SPAN relay. We call SPAN this one made by Schneider. This is motor protection relay. We use for this relay for different protections, for for short circuit, for earth fault, overcurrent, under voltage and for over voltage. We inject 3-phase voltage through bus metering VT. We inject 3-phase here in this relay, and also we given 3-phase CTs value in this relay. And we can see here how much is our load. We can see here in this relay. And for example, my bus CT is 600 by 1 amp. The rated value of CT is 600 by 1 amp. If my primary side is 600 ampere, so my secondary side should be 1 ampere. And same thing in VT values. If my primary side is 13.8 kV and my secondary side will be 115 voltage. So we are giving 3-phase voltage in this relay, and we can see here value 13.8 kV is phase to phase and 7 point something is phase to neutral. And then how much is our load we can see also here in this relay, and we put some values in this relay. How much is rated, how much we select value, current value in this relay, how much is our actual value in system, how much we are using load in our system. So we put here in this relay, for example, in my system I use 100 amperes. I select in this relay 100 amps for our current value, and then also I select timing of our current for our current 2 seconds, 4 seconds like this. And short circuit I put value very less value 200 milliamps, and for earth fault also 200 milliamps. So how to work this relay? If my side any problem and my motor values and my motor load increase, the rated load is 15 amps. So when the increase the load of motor up to 15, this will be given first time alarm overcurrent, and the second and the within selected timing this relay will be tripped. For example, my selected time is 4 seconds. So within 4 seconds this relay will be tripped and given alarm overcurrent. And also we use for under voltage and for over voltage, and selected value and selected rated voltage in this relay I selected plus and minus 10%. If my voltage is increased up to 10%, that means this relay will given a alarm for over voltage and will be tripped within selected timing. And my selected time, for example, my selected timing is 7 seconds. So within 7 seconds this relay will be tripped And for under voltage, same work, same like work, minus 10% decrease the voltage of rated voltage. This relay will given alarm, first time given alarm under voltage and will be tripped within selected timing. So this is under voltage, over voltage, and for over current. And for earth fault, we use a round type CT. We use round type CT or output cable. We put inside the output cable round type CT used for earth fault, and the rated value of earth fault CT is 100 by 1 amps. If my primary side is 100 amps, so should become in secondary side 1 amps. And and I select in this relay my rated amps, and I select in this relay my rated value is 10 amps, and my secondary side will become 0.1 amps. If my cable sense, if my earth fault cable CT sense 10 amperes primary side, for example my cable damage or something, or bit grounded, any phase grounded, so this CT will be sensed, and when up to 10 amps this will sense and given to alarm here, and this relay will be tripped within millisecond, within 200 milliseconds. This is very short time for safety of this feeder and for persons and for different for motor. This is for earth fault protection. And next thing is lockout relay. Lockout relay, we call, this is made by GE, and we use this lockout relay for safety of reclosing of breaker, for breaker safety. If any happen, will come outside the system, or our system, or our system, if any happen will come, for example short circuit or earth fault, this relay will be tripped and make hold in trip condition. You cannot close your breaker even if you not reset this relay. When you reset this relay, you can reclose your breaker. And this relay used for safety protection of breaker. And next thing is the local remote control switch. This local remote control switch used for two things. One, for manually close the breaker, we put on local. So we can reclose and for trip breaker easily here. And for the next thing is put on remote condition. You can close through DCS, through your signal from CCB control building. You can close this breaker through CCB control building with your signals. You can close or can open breaker when you put the remote condition. And next thing, this was this control switch. This have two positions. One is closed and one is tripped. This is used for breaker. We can, if we want to close, we will put in this closed condition, and if we want to trip our breaker, we will put on trip condition. These are 4 or 5 indicators, and these indicators used for different conditions. Green indicator we use for normally breaker open, red indication used for breaker close, and yellow indication used for tripping, and white indication show the charging of breaker. When breaker charge, this indication will be below, and the 5th indication used for tripping, for any fault condition breaker tripping. And this is single layout diagram. This is bus bar and our 3-pole circuit breaker, and the CTs and indicators and earth switch. These all things you can see in one single layout diagram. And we are using also vacuum type circuit breaker SF6, and this is made by Schneider. The rated value of this breaker is 13.8 kV, and the over voltage is 13.1 kV. Will be tripped within 7 seconds. Under voltage is over voltage is 38 kV within 1 minute, and under voltage is 17.5 volts, kilovolts. and the rated current is 630 amps of this breaker, and frequency is 15 hertz or 16 hertz. You can choose on these two values for this breaker. And this is made by Schneider, and we have also one switch used for protection of this breaker. So these all things I want to explain with you. And the one more thing, we test these all things. How do we test these all things? This actually they will test through Friga. We inject 125 volts on coil of this relay and check the timing through binary contacts, how much timing for tripping timing of this relay. And we also use and we also test pickup of this relay, how much pickup voltage through Friga. Inject the 0 voltage and increase slowly and check how much voltage take for pick up this relay. I think more than 70 voltage is pickup voltage of this relay, and drop off voltage. When we want to check drop off of this relay, we will decrease the voltage slowly and check how much voltage take for drop off voltage. And this will be trip, I think less than 30 volt, less than 40 voltage is drop off voltage of this relay. And next, this multifunction meter. This multifunction meter also we test through Friga, through CPC, and we inject 300. We inject 3-phase voltage through Friga and 3-phase current through Friga. We inject here and check the values. Actual values we inject 4 values: 0.25, 0.5, 0.1 through Friga, and check the values. And check the values on this multifunction meter, how much giving error, and we check the error of actual values and the rated values. And we also will inject the same thing. We inject rated voltage through Friga, inject the voltage and check the error, how much error is giving, and then we check different values on different angles. We inject on different angles, 90, 180, like this, and check the values of each phase, power factor, active power, reactive power, how much reactive power, how much active power take. We test this. We test for active power 5 minutes with selective timing and check how much inject rated voltage and rated current, and check how much is the active power. So pulse of we check pulse, and this protection relay we test through Friga. Also we inject 3-phase through Friga voltage and current, and we inject 3-phase voltage through Friga and increase the voltage up to 10% and check how much timing take. Timing we select also timing inside the relay, and then we check and we check our relay is tripping within our timing, selective timing, or how much error is the actual timing or rated timing. For voltage, over voltage, for under voltage, and for all fault, these all things we tested through Friga, inject the values and check the time, how much timing taking for tripping, and check the error. And also this relay, lockout relay will test through Friga, through Severco. We inject the voltage 125 volts DC through Friga and check the timing, how much timing take for tripping and tripping timing. And this all things I want to explain with you. And the breaker test, with breaker test we timing test we test through Eagle breaker timing test, and with graphic for closing timing, for opening timing, and opening and closing timing with graph through Eagle. And also we test different things. So from different components I have tested, I have worked on the biggest power plant, biggest Gulf power plant, Korea power plant. I have worked there, testing and commissioning, operation, maintenance, and different fields. So I have some experience on power plant and through power plant and this fields, operation field. So that's why I want to explain to you. We tested their cities with specialist city analyzer Omicron, made by Omicron, and also CPC used for British test British tests, also made by Omicron City, made by Australia. And these all things we test. We use Friga, Shivarkar, Magnus, MOM, CT analyzer, CPC, Fluke, Maker. These all things we have used on power plant for test different type of components. CT slope test, primary injection, secondary injection, breaker test, relay test, or control circuit test, schematic test, function test, interlock, intertrip, and different type of things. Different things we tested from different instruments. These are all instruments we have used on a power plant. So these all things I want to explain. I hope you will be like and given good comments. Thank you very much. Assalamu alaikum. Goodbye. Assalamu alaikum. Hello everyone. My name is Ashif Ali, and in my next video I will show you how to operate the function test of medium voltage switchgear and how to work the switchgear components. So I will start now. Before I told you about the control switch of breaker and the control and local remote switch. So now I will show you how to operate these things. So first of all, I have two conditions. I have two things. First one is earth switch, and if my earth switch is closed, so I cannot operate the breaker. I cannot close the breaker. Now my earth switch is open. I can close the breaker. So I can show you here. This one is earth switch, and my earth switch is in open condition. So I can close the breaker. I will try to close the breaker through control switch. So when I push the on closed position, this breaker will be closed. You can see here, red indication is coming here. So that means my breaker is closed and my breaker also charge indication. So when I push on the trip condition, this breaker will be open and indication, both indications are coming. One is for breaker and one is for charge. So this thing is for breaker closing. If my switch is closed, I cannot close the breaker here. When I will put a switch in open condition, I can close the breaker. So now I will show you how to operate this lockout relay. So here is now the actual situation is my breaker is open. Now the actual situation is my breaker is open when I close the breaker, and I try to close the breaker because my switch condition is my switch is an open condition. I can close the breaker. Yeah, I can close the breaker. When I try to close the breaker is closed. Now what I will do, I will operate the lockout relay and this breaker will be open. See, now my breaker is open and the lockout is operated. When lockout is operated, you cannot reclose the breaker. See, I cannot operate the breaker. I cannot close the breaker. My lockout is in lock position, so I cannot close the breaker. When I reset the lockout relay, I can close the breaker. See, now my indication is glowing red indication. That means breaker is closed and also in charge. So now I retry to open the breaker through lockout relay. As lockout relay is operated in earth fault condition or short circuit condition, my breaker will be open and cannot reclose the breaker. Through local or remote, in both conditions I cannot close the breaker. Now the breaker is open and lockout also is operated. So I cannot reclose the breaker. See, I cannot reclose. So when I make reset, lockout, I can close. Now, see, okay. So this is interlock. This is low condition for lockout. This is how to operate lockout relay. I show you how to operate lockout relay. When lockout relay is operated, I cannot close the breaker. So this thing and also indication is glowing here on the relay. This indication showing me the breaker is closed. When the breaker is tripped, here is the green indication will become, that means this breaker is open. So now I open the breaker and green indication is glowing here. So this is for breaker, right? And now I want to show you more about the control circuit, control wiring, So this is, first of all, I have some breaker control breaker, auxiliary breakers. These are first one is for protection, and next one is for control tripping circuit, and then next one is the indication meter metering circuit, CV control, motor circuit, charging circuit, control for breaker, and panel heating and lighting auxiliary breaker. This small breaker, 2-pole breakers, and this indication is blowing this for module. This is for transducer module, for signals and for rating. This for SCADA. This we use for SCADA through modem cable. This modem cable is going to SCADA panel, and then SCADA panel through CCB control building. Now I want to show you this terminal box is for cities. You can see here, this is for you will use for cities terminal box, and cities terminal, and these cities are coming here in the multifunction meters, in the relay, and in the relay. So also there is another is for BT. So both terminals used for cities and BTs we use here, and connect here cables, yellow cables for cities and blue cables for BTs. You can see here on the multifunction meter, these are made for these are used for current measuring and for voltage measuring. Now I want to show you this multifunction, how to operate this multifunction. We can check here voltage, phase to neutral, and then current, then power factor, active power, reactive power, and apparent power. These are things we can see here on the multifunction meter. And this is relay. This indication is glowing and show you the breaker is closed. When I open the breaker, this indication will go on, and another indication will become. This indication show you your breaker is open. This is protection relay, spam protection relay. I told you before about the storm protection relay. This protection relay used for different protection, for over current protection, under voltage, over voltage, earth fault, and short circuit. We use this all for. You can see here, this is you can see here, this is over current. We use for over current, earth fault step 1, step 2, over current step 1 and step 2. These 4 indications are flowing here on this relay. If any happen will come, this happen will come. For example, for over current will come first stage, and this indication will be below, and in second stage this indication will be below, and the earth fault first stage and the second stage. This whole stage, if any if for short fault will become, and this indication will be below on the indication. You can see also in this relay phase to neutral voltage, phase to phase voltage, your load, and you can also see which time your breaker closed and open, or for keeping under voltage, over voltage. This all information saved in this relay, and this used for local and for remote. You can control this relay to local and for remote conditions. Both conditions you can use this relay. We set the rated what we need load. We set in this relay, and this relay sends. If the load is going to raise, this relay given first stage over current, and the next stage this relay will be tripped and show the indication here. In short, in earth fault condition, this will be tripped within 200 milliseconds and show the here, and your breaker will be open, and the lockout also will be operated, and you cannot reclose your breaker. You cannot reclose your breaker when you reset your close. And first of all, you will solve your problem, short circuit or earth fault, then you can reset your lockout relay and you can close your breaker. These all things. This one is relay giving their flight. These two flags are dipping, going for dipping, and this relay contact used for DCS for signals. and this auxiliary we use for control circuit, for DC control circuit, and for breaker tripping. Mentioned here on this flag mentioned here, if breaker is tripped in condition 1, flag display show the flag, red flag, that means your breaker is tripped, and you will reset the flag and reclose the breaker. This one is tripping 1 and this one is tripping 2. This is all components. I show you how to operate this component, or function test, how to function test medium voltage switch gear. In two conditions, the earth switch is closed, you cannot close the breaker. When you open the earth switch, you can close the breaker. Hello everyone, my name is Asif Ali and today I am showing you battery test. First of all, after finish the charging 48 hours, I will start this test. This test called battery test. This instrument is Torcal 720 and we are injecting load through this tester. This is batteries and how we can inject these batteries amperes like this. After finish the charging 48 hours, we start this test. We are injecting load through this tester. This tester called 720 Torcal. This is made by programmer. And how we inject this test? This test have multifunction testings. First of all, we see how much we are total voltage. We have 125 volts, 125 volts DC. So we set here 120 volts, and also we connect the cables in this tester. After that, we start here. When we inject this voltage, showing here 125 volts and injected current is 22 amps. Now the 25 minutes have gone and the injecting and the voltage decrease each hour. Now the voltage is 107. After 5 hours, this test is totally 5 hours. After 5 hours will be finished, this voltage will be decreased each hour and the value of current will be increased each hour up to 110 amps. After finish this 5-hour test, this voltage will become less than 100. Before testing, we have these values 1.42 volt each cell. Each battery have 2 cells and each cell's voltage is 1.42. After finish, this should become 1.0 volt. If less than 1.0 volt, this means this cell is not good or not for work. Thank you so much. My name is Asif Ali and I hope you will be like my video. Goodbye. Khuda Hafiz.